So today we're going to look at uncertainty in measurement. There's always some uncertainty in measurement due to the fact that the last digit is estimated. So you can read the example up there. And then it says, in example 1, we're going to run through this. It says, how should the length of the pencil be recorded for each of the rulers? If I went up and recorded these, this looks like this would be about 6 point, I don't know, I'm kind of estimating 6 centimeters. This other one, it is marked off to the 100th place, so I would probably go 6.6, it looks like, and a little bit more, 6.62 centimeters, because I got to estimate the 100th. This one I estimated the 10th place. So when recording a measurement, we need to write all certain digits, so that's everything that is marked off on the ruler, and one uncertain digit, or estimated digit. Okay, and that is only 1. You only estimate 1. So in a measurement, the last digit on the right is always the estimated one, or the uncertain one. And the uncertain digit usually is 1/10 of whatever the increment is on the measuring device. So you usually take that, like on this, we would take and we divide that into 10 equal spots. Typically, I would go right in the middle and say that would be the 0.5, and then from there I would divide it. Okay, so significant digits and significant figures include everything that is certain and then one uncertain digit in the measurement. Okay, that is the correct way to read those. So we're going to look at a couple examples here. Example 2, it says, what's the difference between the following? I have 1 dozen of eggs, has 12 eggs, and then I said 1 egg has a mass of 12 grams. This is a count. A count is an exact number. This is a measurement. A measurement is not an exact number because one digit is estimated. Or we could say that's inexact. Let's spell it right. E-X-A-C-T. Okay, so measurements have some inexact digits in them where an exact number, a count, doesn't. So that would answer this question right here. Okay, so a count, it is exact. No uncertainty. A measurement, it is inexact and has uncertainty. Because of the last placing on there. Okay? So, on this next one, if I had the length of an object is recorded to be 350 centimeters, they want you to sketch the ruler. So in other words, if it's written like this is certain and this is estimated, and this 0 here is just a placeholder. It's just holding the place for the ones place. Okay, so if I was to sketch this, it would look something like this. So the hundreds are marked, those are certain, the 200s, the 300s, and then there's 400. That's all the markings that would be on there, because you're estimating the tens place. So what does the roll in this measurement? Isn't this that placeholder? So it's just holding the place for the 1 position. How would you record the measurement if the 0 were the uncertain digit? So in other words, if 0 wasn't just a placeholder, you would record it like this, 350 with a decimal. This means when you do put the decimal there, because this one did not have a decimal in it, this is certain, and this is the estimated one. Okay, so the decimal signifies what is the estimated digit, how far. Okay, so here's the rules. All non-zero digits are significant. All non-zero numbers, those are the numbers between 1 and 9, they're going to be significant because you either read those off the ruler or else you estimated those. Leading zeros are never significant because these are just placeholders. So in other words, like if I had 0.0125 centimeters, these two zeros right here are just placeholders. They're just placeholders to hold the 1 spot and the 1/10th spot. Okay? Captive zeros are always significant. So that would be something like if I had 405 meters, guess what? This would be certain, this is certain, and then this is the estimated. Remember, the estimated is that last digit on the right. And if it's the numbers between 1 and 9, it's going to be estimated. So you have to count it. Now, the other one, that type of zero, so captive is they're caught in between two numbers between 1 and 9. Leading is they're out in front. So the other type of zero is trailing. They're only significant if you have a decimal point. So if you had 25.00 milliliters, this would be certain, 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 estimated. If somebody wrote 250 milliliters with no decimal, then this is certain and this is estimated. That last zero is a placeholder again. Okay? So here it says underline and count the number of significant figures. I'm just going to underline. You can count them. We have different types of zeros. Sometimes we have, like in this one, we have leading, trailing, and captive. This is a count. Remember, a count has no uncertainty, so everything counts. And then this one right there, there's no decimal in this number, so it's everything in front of that final 4. Okay? Now, the nice thing about scientific notation, it's a nice way to write very large or very small numbers, and it also is recorded with the correct significant figures. Everything is always significant. So the rule is, if I wanted to change 25,000 grams, I'd move the understood decimal right there, 1, 2, 3, 4 places, because I want to make the number out in front here between greater than 1 but less than 10 times 10, and then I'd put an exponent 4 grams. Okay? If I did this number, I'd move the decimal 1, 2, 3 places to the right. I would write the number as 1.3, it's greater than 1, less than 10, times 10 to the negative 3 meters. Okay? This should be kind of a review. Reverse and do the other. So this is a negative 2. That means I need to move the decimal 2 places to the left. So my number would be, going back to standard form, 0.01300 liters. I got to include those. They're significant. And on the last one, this would be 45.2 centimeters. I'd move my decimal 1 place. Okay? So that just goes through a few examples there. Now, we need to know how to do some calculations or operations with significant figures. So we're looking at doing these. To do these, there's 2 rules. When you multiply and divide, you look at and you do the math for this. So if I did the math for this, I'm going to have to calculate this. Example of multiplying and dividing. So here's what it is. So when you multiply, if I multiplied this out in my calculator, I got 1,608.75 centimeters cubed, because I took centimeters times centimeters times centimeters. So what I do is I look in the measurements. This one has 2 sig figs. This one has 4 sig figs. This one has 3 sig figs. I choose the measurement that has the least number of sig figs, 2. So I need to round this number. It would be 1,600 centimeters cubed. I wouldn't put a decimal in there because the 2 zeros are not significant. If I did this other one, if I did this math, I got in my calculator 333.2631579. I'm not going to carry my answer that far because that would mean my equipment was very precise, and it wasn't. I look in here and I go 2 sig figs, 4 sig figs. 2 is the fewest sig figs. I'm going to round this answer to 2. That would be 330 grams per centimeter. Okay, so it's just rounding it to the measurement that has the fewest number of sig figs. Okay. So we will touch on this later, multiplying and dividing in one problem. You usually do it step by step, and we'll touch on that later. So when multiplying and dividing, you record your answer with the least measurement having the fewest significant digits. So you look at the entire measurement. Now, when you add and subtract, the rule is a little bit differently. So when I added up these numbers, for this one I got 110.35. Okay? Now, and this would be just centimeters because we're just adding. So when I look at this, I only look behind the decimal when you add and subtract. There's 2 sig figs, 1 sig fig. There are 3 sig figs. Same thing. I'm going to choose the least. I can only have one place behind the decimal here, so I would round this to 110.4 centimeters. Okay, so the difference between this and the other one is you're only looking behind the decimal. If I did the other problem for math, I would have gotten 2.3. There's no units on there. Now, the thing is, I have 2 sig figs here and I have 2. I need 2 here, so I do need to include that 0. Okay, so when adding and subtracting, you record your answer to the place of greatest uncertainty behind the decimal. Oops, behind. The greatest uncertainty will have the fewest places behind the decimal. So that's the difference. Adding and subtracting, you only look behind the decimal. Multiplying and dividing, you look at the entire measurement.